Okay, so let's take a look at our computer simulation. Now you might say to yourself, wait, I thought we were going to do a computer simulation. And yes, I was hoping we would do one too, but I'm having this problem where I can't record video off my computer screen. The audio's not coming out clearly. So I can only right now record video off of my annotated iPad. So that's what we're going to have to do. I did screenshots of the computer simulation. And when we get back together next week, maybe we can take a look at it live if you'd like. So, like I said, what I had my computer do was I had set up a container or an urn filled with balls. And there's going to be 24 red balls and 24 green balls. And again, the red balls are going to represent the female applicants and the green balls are going to represent the male applicants. I'm asking my computer to draw 35 balls out of the urn. And then what we're going to do is we're going to count the number of red balls in the sample that we take, and then we're going to graph them. All right, so this is what that would look like one time. So it took 35 balls. If you took a moment to count, there's 35 balls in that picture, red and green. And the number of red ones in that scenario is 17. So in this simulation, 17 women got promoted. And then I have my computer graph at 17. So we can see that there was one sample where 17 women were promoted. So that's doing it one time. I'm going to show it to you another time just so you kind of get the idea of what's going on. All right. So I had it do it again. So it drew 35 balls out of the container. It counted the number of red ones. And in this sample, there were 14, just like in the actual case that we're looking at, 14 women promoted. And so then I had my computer graph that one. And so for a 14, there was one sample with 14. So we've done it twice so far. One had 17 women promoted. One had 14 women promoted. And now what I'm going to have my computer do is do it 1,000 times. It's going to do the same thing. Take 35 balls, count the number of red ones, record it. 35 balls, count the number of red ones, record it. And we're going to take a look at what the graph looks like. So I had my computer do this 1,000 times, and down here you can actually see the numbers of samples it took. So if you were to spread that out, it actually records how many red ones and how many green ones were in each of the samples. But here's a graph of them. And what I'd like you to notice is how often did we get 14 or less red balls? In other words, how likely is it that just simply by chance, only 14 women or fewer get promoted? And according to this simulation, if we do this 1,000 times, the number of times where we got 14 red balls or less was only 20, or in other words, 2%. So there's only a 2% chance that that happened by chance. All right. So is it very likely that if there's no discrimination going on, if we're just promoting equally across the board, how likely is it that we'd only see 14 women promoted? Only a 2% chance of that happening. And so what's our conclusion? It's very highly unlikely to only see 14 women promoted. And since it's unlikely that if purely by chance we only would see 14 women promoted, that gives us a case for discrimination.